Hello, viewers. In today's session, we are going to discuss another important and conceptual problem from domain of functions. And here we are going to find out the domain of this function f of x, that is equal to square root of sine inverse 4x plus pi by 6, right? So this problem is an easy problem, and here we have to just make use of the principal value branch of inverse sine function, that is the range of sine inverse function. So let us see how we can easily find out the domain of this function using the concept of range of inverse sine function. So let us start. So now from inverse trigonometric functions, we know that the range of sine inverse theta, it belongs to the interval minus pi by 2 to pi by 2. When theta, it belongs to the interval minus 1 to 1. So here we'll use this concept to find out the domain of this function, right? Okay, so now here we have the square root sign. So the first condition is that this entire term, that is sine inverse 4x plus pi by 6, should be greater than or equal to 0. So this term should be either 0 or it should be a positive, because we cannot have a negative number inside the square root sign, because in that case this number becomes a complex number, right? Okay, so sine inverse 4x plus pi by 6 should be greater than or equal to 0. So from here we can now write sine 4x is greater than or equal to minus pi by 6. So taking pi by 6 to the right hand side. So here we have this inequality, right? Okay, now let us come to this range of sine inverse theta function. Now here we have sine inverse 4x. So if we take theta is equal to 4x, then sine inverse 4x should belongs to this interval, that is minus pi by 2 to pi by 2, right? So here we have sine inverse 4x belonging to this interval. So here we have minus pi by 2, and here we have pi by 2. Now see, from this inequality here, sine inverse 4x should be greater than or equal to minus pi by 6, right? So here it is an important point to note that minus pi by 6, it lies between minus pi by 2 and pi by 2. So here we have minus pi by 6, and to fulfill this condition, sine inverse 4x plus pi by 6 should be greater than or equal to 0. Sine inverse 4x should be greater than or equal to minus pi by 6. So here the minimum value of sine inverse 4x should be minus pi by 6, and sine inverse 4x can go up to pi by 2, right? So now we can modify this inequality, or we can merge the inequality, that is sine inverse 4x is greater than or equal to minus pi by 2 and less than or equal to pi by 2. So if we merge these two inequalities, then we should have sine inverse 4x should be greater than or equal to minus pi by 6, but it should be less than or equal to pi by 2, because here sine inverse 4x is greater than or equal to minus pi by 6, and minus pi by 6, it lies between minus pi by 2 and pi by 2. So we have to consider only these two points, that is minus pi by 6 and pi by 2. So now we have this inequality, and from this inequality we have to find out the valid values of x for which this function is defined. So now let us take the sign of each of these three terms. So we have sine of minus pi by 6, and then we have sine of sine inverse 4x, and then we have sine pi by 2. Now sine minus pi by 6. So sine minus theta is equal to minus sine theta. So sine of minus pi by 6 is equal to minus sine pi by 6, and sine 30 degrees is half. So here we have minus half, and here using an important property of inverse trigonometric function, that is sine of sine inverse theta is equal to theta, right? So here for theta we have 4x. So here we have 4x, and sine pi by 2 is 1. So now dividing throughout by 4, we can now write minus 1 over 8, dividing throughout by 4. So 4 times 2 is 8, and here 4 and 4 get cancelled. So we have here 1 over 4. So the values of x for which this function is defined is given by this interval, that is from minus 1 over 8 to 1 over 4. And remember, here this interval is closed from both the ends. So minus 1 over 8 and 1 over 4, both the points are also included, right? So this is how we can find out the domain of functions of these types. Hello viewers, in today's session we are going to discuss another important and conceptual problem from functions. And here we are going to discuss this important problem where we are given two functions, g of x and f of x. And g of x is given as x minus greatest integer of x plus 1, and f of x is defined like this, that is f of x is equal to minus 1 for all x less than 0, and f of x is equal to 0 for x is equal to 0, and f of x is equal to plus 1 for all x greater than 0. And here we are given the composition of f and g, that is f of g of x is equal to 2 alpha minus pi, where alpha belongs to the set of real numbers. And here we have to find the value of alpha, right? So let us see how we can find out the value of alpha using the concept of fractional part function, right? So let us start. So now the fractional part function is defined as fractional part function is defined as the difference of x and greatest integer of x, right? So the fractional part of x is defined as x minus greatest integer of x for all values of x belonging to the set of real numbers, right? And here we have x minus fractional part of x. So we can now write a g of x as fractional part of x plus 1, right? Now let us see the range of fractional part function. Now we know that the range of fractional part function is given by this interval, that is 0 to 1. So here 0 is included and 1 is excluded. So we can also write it like this: for all values of x belonging to R, fractional part of x lies in the interval that is 0 to 1. So here fractional part of x is greater than or equal to 0 but less than 1. So now let us add 1 throughout this inequality, because here we have fractional part of x plus 1, right? So adding 1 throughout, we have here 0 plus 1. So we can now write here 0 plus 1, and here we have fractional part of x plus 1, and here we have 1 plus 1. So 0 plus 1 is 1, and for fractional part of x plus 1, we can now write the function g of x. So here we have g of x, and here we have 1 plus 1, 2. So from this inequality, we can easily conclude that the function g of x, it belongs to this interval, that is 1 to 2. So here 1 is included, right? And from this interval, we can easily conclude that g of x should be a positive number. So this is an important point while solving this problem, right? So g of x must be positive, because g of x, it lies in the interval, that is the positive numbers 1 and 2, where 1 is included. So now let us come to the composition of f and g. So here we are given f of g of x is equal to 2 alpha minus pi, right? Now see here, we have f of g of x, that is the input is g of x, right? And we have just shown that g of x is a positive quantity, right? So we have f of some positive number here, because g of x is positive, and here we have a 2 alpha minus pi. Now f of some positive number is equal to 1, because here f of x is defined as f of x is equal to plus 1 for all x greater than 0. So it means this x is positive. So f of x is equal to plus 1 whenever this x is positive, right? So f of positive number should be equal to 1. So whatever be the value of g of x, where g of x belongs to this interval 1 to 2, where 1 is included, so f of some positive number should be equal to 1. So here we have 1, because f of positive number is equal to 1. So we have now this equation, that is a 2 alpha minus pi is equal to 1, and from here we can easily find out the value of alpha. So we have 2 alpha is equal to 1 plus pi. So we have alpha is equal to 1 plus pi over 2. So this is the required value of alpha when g of x and f of x are defined in this way, and we are given the composition of f and g as equal to 2 alpha minus pi. And here it is important to note that g of x cannot be equal to 0 for any value of x belonging to R, because g of x belongs to this interval, that is 1 comma 2. So here we cannot have g of x is equal to 0. So g of x is always going to be positive, and f of some positive number should be equal to 1, because f of x is defined as plus 1 for all positive x, that is x greater than 0.